Hello, everybody. I'm going to continue talking about the internet layer. Before I go into IPv6, I want to give a better example of the network address transaction. Much of this is based, all of it is based on a Microsoft site that explains how the NAT works. Now, the way we look at it is there's a private network on the left here, okay? That network contains one or more hosts. Each of those hosts has only one IP. They have many sites on it, but only one IP. Now, we have let's give it a makeup address. Let's pretend it has the address 124.68.58.30. Now, a client on this host wants to download from a TCP server at port 80 on the IP, let's say 68.126.43.20. Now remember, these are made up numbers. I'm just putting them down to have something to talk about. This server is on the public network, the internet, i.e. the public network. Now, what happens? Well, we're now going to talk about what happens at the router. First, I think I'll go with putting points down. What happens? The router has an address for the incoming line from the private network. Let us say that address is an address, pardon me, I left out the word, an IP address. Let's say we'll give it, it's on the same network as the host is. So let's make it 128.68.58.50. The client at in the private network sends an email, sends a datagram. A datagram is just the message that is sent in the internet layer. Sends a datagram to 128.68.58.50, in which it gives its number, its IP, which we had up here. I'll just copy it. Its IP. Pardon me, I didn't hit it hard enough. Now I get it. All right. So it gives its IP. And a port number. Let's a port number, say 3864. That's a made-up number again. Okay, so, and it also says, and it gives the IP address and port 80 for the server it wants. Now, what happens next? The router, the NAT router, converts this request to a request from its public IP address, say 176.59.45.73, and a port number, say 3219. It sends a request to the client that the host on the private network wants. But the host thinks it has a request from socket 3219 at the host with IP address 176.59.45.73. So what you can see is, as far as the public world is concerned, that address covers the entire private network. It's the only address the rest of the internet has for that private network. And the rest of the network thinks that's where it's everything's going. Now, the server gets the request, which, as you may remember, is a SYNC-ACK. It's the beginning of the three-way handshake, and replies to the socket at that address. the NAT router now translates this address into the socket number and IP of the client on the private network, and sends the information to the client. All the work has been done by the NAT router. In other words, it's a port on the internet. It's how that entire private network gets to the internet. And as far as the private network, the rest of the network is concerned, there's one address. And as far as the private network is concerned, there's one address to get out. The NAT router has two addresses. It has one to the public world and one to the private world. And there could be several hosts on there, each one with one IP address and many sites on it that don't have to have their own IP addresses. And that's the beauty of the NAT. We don't have to assign one address for every possible host in our private network. The drawback, if you think of a drawback, is that the rest of the world has no idea what's going on behind the scenes. So this might be better than a firewall. It prevents us from even knowing what's there. We can't find out because all we can do is send a request to the NAT router. Now, it's possible the NAT router could then could broadcast information. It could say, I have a TCP server here. I have a DNS server here. It could set up a table like that and advertise it to the rest of the world. So that's the way the network address translation works. It appears to be still in use. The Microsoft site does not imply that it's an ancient site that is no longer in use. And just to make sure, the word router or whatever you want, that just is a piece of hardware. In that piece of hardware is the software that's needed to take information that comes in from one line at the IP level and send it out to a different line based on the software in the router. The network is held together by its routers. Those are what put the network together, at least at the level we're at, which is level 3. We'll find out there's some things that look like routers at lower levels. But the routers are the glue, or whatever you want to call it, that holds together the different autonomous systems. The routers are mostly made by Cisco, and those are the things that have to change if we're going to do a lot of IPv6ing. The next one video I'll put out will talk about IPv6. I have found a site that tells us exactly how many of the world's sites have converted. And you're going to be pretty surprised that even many of the top sites haven't converted yet to the IPv6. It's a very slow process. So that's it. Have a good weekend. See you later.